Hi, my name is John Peppers, and I'm an engineer on .NET for Android and .NET MAUI. And what I want to share today is this is just kind of a example of how I do performance investigations. So that could mean something slow, it could be a memory leak. So I'm going to show how I do that and just some general tips for performance. This was a talk that I gave internally, on Teams at Microsoft. So I felt like this is something that I could record myself again, and hopefully it all works in uh, one shot. I just press record. So we'll see how it goes. Yeah. So let's say you have the problem of my app is slow, or I have a memory leak, or so forth. Um, there's a couple things you could check first, and we'll go through those. I'll show examples of how to profile an app. I'll do it from scratch with a project template, and I'll do it on Android because that's the more complicated one. And I'll show all the commands to run and so forth. Um, and then I'll give some examples of some XAML that might not be the fastest option. So, so before you do anything, um, the first thing you might check, um, if you feel like your app is slow, is it slow in release mode, right? Debug mode has a lot of settings that are enabled for productivity, like hot reload, but they actually can make general code in your app slower than it would be in real life when you go to distribute your app. So for example, the setting use interpreter true, it's on by default for debug, and that enables C# hot reload. So you could change like a body of a method and you click that little fire button in Visual Studio, and now VS Code has it too, um, and that will reload your code live. But that enables the mono interpreter that is actually a bit slower in running code generally. Um, Same with XAML hot reload. It actually parses the XAML when in debug mode when you have this XAML hot reload enabled. Um, and while in release mode, it will like pre-compile all the XAML, so there's no parsing happening. Um, so that's another reason things can be slow. So also check, if you haven't tested your app on a physical device and you've only been testing on a simulator or emulator, um, physical devices tend to be a bit faster because, A, they're not emulated, but they also have hardware acceleration for what's happening on the screen, while many times uh, the simulator or emulator are not hardware accelerated. Um, and then if there's a link to check here if you've not seen AKMS/profile hyphen Maui, that has a lot of details about this stuff at the top, and it has links to how to profile and other things. And if you do find that, hey, this thing is slow and you're using a particular feature of Maui and it's slow and you don't think it should be, file an issue, like make a sample, that will help us, improve the product in general. So let's talk about the different tools you might use. Here's an example of some of the problems you might encounter. So let's say your app launches slow and you want to speed that up. That's more likely to happen on Android, I think. And so you could record startup with dotnet-trace in suspend mode. Um, and, another idea or another problem might be there's a particular screen that's slow. And so in that case, you don't need to record startup, you need to record just that screen. So you might use no suspend mode, and I'll talk about what that means. But suspend in general, when the app launches, it will block and pause until dotnet-trace attaches. And I'll show an example. Same thing with scrolling. You would want to just attach dotnet-trace like while you're scrolling and then stop it and then look what happened. Um, and for a memory leak, you'd use a completely different tool. You'd use dotnet-gcdump. And I'll give a demo of all of these in a minute. Now, if you're fortunate enough to have the problem on Windows, it's actually much easier to get this information. You can basically just open Visual Studio and just clicking a few buttons do everything you need to do. Right? You could go to the diagnostic tools menu, and there's a section called CPU usage, which kind of is the same information as dotnet-trace. And then the memory usage tab has kind of the same information that dotnet-gcdump will give you. And so if try this menu first, it's pretty easy to use. You can just click and do what you need. And then you can even save the files out if you need to attach those to an issue, or you need someone else to look at what's going on. That's what I would do. But the problem, like why mobile is more complicated, is just generally like we don't have the ability to push a button in the IDE and do all the stuff for mobile yet. That's something that we would like to happen in the future, and hopefully someday we can. So let's talk about how you set up on mobile. There's 3 tools, gcdump, dotnet-trace, we've already talked about, and then this third tool is dsrouter. In general, what it does is it will talk to a remote process on a mobile device or emulator or whatever, and it will kind of forward the profiling or tracing information from that device to dotnet-trace running on your desktop. And generally, it takes a couple terminals to set all this up, and I'll show how to do that. And while tracing, the types of files that you'll get, there's a couple different types. Let's just kind of go through them. A net trace file is what dotnet-trace creates by default, and you can open this in Visual Studio or Purview on Windows. If you're on a Mac or Linux desktop, you might want to use Speedscope instead. And then there's just a website, speedscope.app, that you can open the traces in. And I also think that Speedscope is generally pretty good at showing profile information. So I use it probably the most out of some of these tools. But and then a gcdump file, you can record these on Mac or Linux. But as of right now, the only way to view them is to open them in Visual Studio or Purview on Windows. I heard a community member was working on some kind of Mac viewer thing, or some way to convert it to something that you could open on a Mac, but that we don't have that quite yet. Maybe someday. So let's do a demo. So I'm going to do everything in VS Code just to make it easier. So I've got the terminal and the code, everything right here. But you could do this in any terminal you like, any IDE you like. I'm not going to do anything particularly special here. But let's just start out with creating a project. I'm just going to do .NET New MAUI. And then let's configure a couple settings. So I'm going to open the project. And a lot of these are for convenience. So you might do this temporarily to help trace and then undo everything I'm about to show here. But I'm just going to mainly change these settings to make my command line commands easier. So I'm going to do a single target framework. And what that lets me do is not have to pass -F net 80-Android on every command. So of course, that's optional. And then the first thing I need to do is actually enable the profiler. Android enable profiler. And what that will do is when I build the project, it'll actually add the mono diagnostic component to the app. If you miss this step, basically none of the tracing will work because the tracing infrastructure isn't in the app. So this is pretty important. And I'll have some links in case you get lost or you want to read to follow along. I'll pull up the doc in just a second. But the other thing I'm going to set is I'm going to set a runtime identifier to actually Android ARM64. And that'll just prevent the build from building for 4 architectures. And this is just for me waiting on the build just in a minute. So this is kind of optional, but that way it only run the AT compiler once. And then another setting, this is also optional, but I'm going to set the Android package format to APK just because it will do app bundle by default, and that's a bit slower. App bundles generally are a bit slower to build. All right, so that's all the settings we need. So let's also do one thing in the app to make it slow. So I'm gonna open the main page, and then I'm just gonna go. I'm just gonna go here, and let's sleep for 1 second. Yeah, just trying to put something that'll take time in the app. Did I spell it right? I spelled thread twice. That looks right. I don't know if I have my C# dev kit working. Yeah, let's restart it. I don't know. Hey, it colored. Well, anyway. Hey, that looks good. Is it working? Uh, yeah, wait. Oh, it's loading. Well, anyway, we can move on. We don't have to wait for it. So now at this point, I've got a device attached, and this is actually a device that's plugged in, and I'm showing it on my screen with a program called Visor. You could use an emulator, but I just wanted to show the real deal, and it's also a little more complicated to set this up for a device. So let's just build the app in release mode, and I'm actually going to run the target run. And while that's running, we can actually set up dsrouter. So I can do dotnet-dsrouter. Oh, well, you know what? Let's actually pull up a doc before I do that. Hold on. So AKMS/profile MAUI will take you here. And one of the links at the top is the Android profiling documentation. I recommend following along there in case you miss a step or whatever. It also explains like how to install the tooling. So like before you do anything, you've got to install these 3 .NET Global tools, trace, router, gcdump, and then you want to make sure you have at least an 8.0 version of these tools. This also, everything I'm talking about here is on this doc if you miss something or miss a step or something like that. So I've already got the 3 tools. So I can just run .NET-dsrouter. And then the subcommand I want to run, you could run Android-emu for emulator. But if this is an Android device, so I'm just going to run Android. And it'll kind of print out a lot of information. But one thing to note when you do this for a device is that it's going to listen, the app is going to listen on port 9000, but dotnet-router is listening on 9001. And so we got to run a command to kind of connect those 2 ports together, or none of this is going to work. So let's open another terminal. And it's in my history, but ADB reverse is going to hook these ports together, basically. So the local port, I think 9000, the Android app will talk to 9000, and then your desktop will talk to 9001. And this just kind of puts them together. And if you're doing this for an emulator, you can skip this step because it's all on the same machine. Okay, so that's hooked up. And the app, I saw it launch. Yeah, it launched over here. So the next thing that we need to do, it tells you about this setting .NET diagnostic ports, right? And so this is an environment variable, and you could set an Android environment variable, but it requires you to rebuild the app and so forth. So we actually have an Android system property that you could use instead. So I'm going to copy this value. It's called debug.mono.profile. And I'm just going to paste this value in. So ADB shell set prob debug mono profile. And so now when the app launches, it will see this setting and act as if it was profiling. So I'm actually, let's do no suspend instead of suspend. And I'm going to close the app and we'll relaunch it so we can kind of see that suspend working. Did not work. Oh dear. Okay, so what I forgot to do before is actually put it in suspend mode. And what that will do is the app will pause on its splash screen waiting for dotnet-trace to connect. So we're going to set it suspend mode. And then we're going to tap the app icon to launch it. And it's going to block there. And then we're going to copy this dotnet-trace collect command that was printed out. And then we're going to say dash format Speedscope as the only change. And so it recorded the app and the app launched. See, we can make it here. And then we can just kind of press enter to let dotnet-trace write out its files. And I've got a couple extra files here. These two look like they're old, this didn't work. But I'm going to open speedscope.app. I use the website. It's not uploading anything anywhere. It just kind of opens the file locally in a viewer. So you can get a Speedscope command line tool. I think it's an npm package or something. But if you'd rather type Speedscope and then the path to the file, you could. And then I'm just going to drag and drop the Speedscope file. And then so this is the default like timeline view. And you can kind of zoom in. You kind of get this nice jagged graph of what happens over time. And then the other thing that you can do is press this left heavy button. And so because we're interested in like basically just startup time, and that's all we recorded, the left heavy button is pretty useful in that it's kind of add everything together and show us what the slowest thing is. And unmanaged code time, that's the biggest bar here because there was just several seconds where I didn't hit enter fast enough. So you may want to zoom in just like that. So we should be able to scroll down here and we can see that the slowest thing is this thread.sleep call that is inside the main pages constructor, which is the thing that we put in here to be slow on purpose. And let me actually zoom this so that we can see it. Yeah, there we go, that was good. So 1.01 seconds, 15% of the total trace time, so that sometimes the percent isn't important. In this case, if I waited longer, then that percent number would change. So it's kind of like the walk 1 second time is more important here. So yeah. Another way to search is you can do the sandwich view. And this is a list of every method that was called. And this is a sampling profiler. So what that means is the way it works is every so many times a second, it records what method is in the middle of being executed right now. And so these numbers here aren't exact times. It's just how many times was this method actually in the middle of running while we recorded. And the numbers here will be a bit slower than real life because the act of measuring performance slows it down a little bit. But once you're in here, we could sort by the total. And then pretty easily, we kind of get down to the main pages constructor. And on this side, we can, let me zoom in again. You can see that thread.sleep is the actual culprit. So one thing to notice is when the bars are like almost extremely wide, that means that this is the thing that still took the most time. So let's say we wanted to do something else. So that was an example of startup. But what if we wanted to measure something like something is slow, right? So let's put this thread sleep in the button click event, and then let's deploy the app again. And actually, let's change it to no suspend now. And then let's build the app again. So this is the app's deploying again. And so what we're going to do is we're going to run the app. We're going to attach dotnet-trace after the app has launched. We're going to click the button a bunch, and then we're going to stop the trace, and then see how that trace compares to the other one we just looked at. So it'll take a bit to build. I'm building a release build, so it's running the AOT compiler on apparently 76 .NET assemblies, but yeah, it's already done. So the app is running. We should be able to just kind of hit up. Hold on, let me get on the right. And then collect a fresh Speedscope. So I'm going to do that. It's attached. I'm going to tap the button over here. Yeah, I can tell it's slow. And then let's stop the trace. All right, we got a new trace. So let's open a new Speedscope. And it's this one, is that right? Yeah. Okay, yeah. So if we look at the timeline view in both of these, you can kind of see that the startup one has these irregular jagged peaks. That's kind of what things are going to look like as you're loading screens. But in this case, we're tapping a button over and over, and so the same thing is happening over and over and over. So if you look at a trace of scrolling, it may look like this, but maybe the bars are really tight, really small. But this one you can do left heavy is even more useful in this type of trace where you've only recorded it for a few seconds and you made the slow thing happen by tapping. You can see pretty easily left heavy. Oh, well, immediately thread.sleep, we spent 6 seconds in there, and that's 63% of the trace. That's the slow thing. Another tip for Speedscope, let's say that you recorded some stuff and then you can't see your code. You're like, what? Where? There's a thread menu at the top. And a lot of the time, if your app launches some thread when it starts, sometimes the main thread will be like thread 4, right? Thread 6, who knows how many threads you launched. And it can be random because I think they're sorted by the thread ID. So the main thread may not always be the first one in the dropdown. So that's just something to be aware of. Yeah. So one last thing. Yeah, the app is still running. So let's get a memory snapshot. So for this command, we're going to do the exact same thing, except instead of dotnet-trace collect, we're going to do dotnet-gcdump collect. Otherwise, same exact command. So that took a snapshot, and I'm going to launch Visual Studio to open it. Continue without code. And if we drag and drop this file in here, what this is a snapshot of every .NET C# object that is alive. And you can see some interesting information about that. So let's say that the problem in your app might be, I navigate to this page, and then I navigate away, and the page lives forever, right? And so you might be interested in finding a certain page. So in this app, there's a main page. And then once you click on it, you get this paths to root menu. And so what this is going to show is, the tooltip might actually explain it some, but let me zoom it. It shows you the path to the thing that roots this object, and why is it alive, basically is what this is. So you can see that the main page was held by a shell toolbar that was held by the app shell that's held in a static variable named application. Let me zoom this wider. Yeah, application current backing field. So application current apparently is an C# auto property, and it's holding a shell that's holding some stuff that's holding the main page, right? So that makes sense. This app isn't leaking. It has one page on the screen. Um, but this hot paths, you can turn it off, and it will show you everything that has a reference to this object. But hot paths is pretty useful, I think, that it kind of identifies exactly what's holding it. And it's not going to be 100% correct, but I found that it's pretty good. So another thing you might look at here is like, let's say we're interested in a button. There's one button in the app, and we can see that the button is kept alive via a main page, via the same stuff, right? And another thing that's interesting is if you think there is a leak, is you can take multiple snapshots. So we can do that. Let me just do that real quick. That sounds interesting. Let me click it a couple of times. I don't know. And then let's do a new snapshot. I didn't mean to do that. So if I open the new snapshot, there's a button called Compare with Baseline. And this will give you a diff of the two. Let me try it. So this one's the older one, I think. Yeah. If it works. Yeah. So this will give you a diff of the two snapshots, and you can see if there's a plus, there are that many new objects than before, right? And this also helps you identify a leak. So you might see that the main page went up by one, but yeah. So in this case, accessibility event occurred. This is probably just something that happens while tapping, in normal operation. And nothing may have even triggered a GC. In this case we're looking at right now, like I just tapped a button a couple times and it has a thread sleep and does some stuff, right? So if no GC occurred, all of the objects will appear here. And so that's why if you're debugging a memory leak, you might like sprinkle some GC collect calls in your app just while you're testing this to figure out if something is leaking or not. Okay. So I think that's all the demo I have. All right. So we demoed profiling in many different ways. So let's talk about a couple examples of performance issues. So these are things that you might have done in your projects on accident or just didn't know the performance implication. So these are basically just tips, but always measure with a profiler. Anything I say here, measure it. So there's probably too much text on this slide, but so one common problem, if you have a collection view and you accidentally, for whatever reason, you put it inside a scroll view, that's going to be a big problem. Basically, the scroll view is an infinite scrollable area, so any control that goes inside of it is going to try to take up all the space it can. So that means if your collection view has 100,000 rows, it will happily load all 100,000 rows up front. When normally the way collection view should work is it loads the rows that are visible on the screen, and as you scroll, it will take the row off the top that's scrolled off screen and reuse it and recycle at the bottom. And that's what makes a fast scrolling collection view fast. But if you put it in a scroll view, that kind of breaks the whole thing. So collection view supports scrolling. You don't need to wrap it in a scroll view. So sometimes I found when people have done this, maybe like they're simplifying their layout or they're in the middle of development and they just kind of forgot and messed this up or something. So that's something to check for. I've seen a few cases of this. We thought about making an analyzer to detect this. It's still an idea we have. We'll see if we can do something like that in the future. So removing the scroll view, free performance. Um, but just the same way that scroll view caused problems, they're also deeply nested layouts can also be slow. So imagine you have like a 3 by 3 grid of controls, and you decided that you put it in a stack layout with a bunch of other stack layouts, and you docked them around to make it look right. Um, so that's an example where you have a bunch of intermediate layouts, and you could just use a grid instead. So all those extra stack layouts, extra time, extra objects to be created, where the grid would be just a single view and get the job done as well. Um, so once you're using grid, you might be tempted to use auto sizing, right? So you might use a column or a row and put width or height auto. So that's another thing that can slow things down. Um, so if you can put a fixed width or height on things, that tends to yield better performance. So another example of this is a collection view row. If you can set a static height on the row, that's going to help general performance of the whole collection view. Um, Same thing with labels. If you have them set to text wrap, that's another thing that can be slow. Um, Other things that are slow are border has shadow and clipping. Well, many views may have shadows and clipping, but those are things that you can turn off and just find out if that dramatically helps your performance. Android has a different like native way to show shadows that you could try. So, maybe file an issue or a discussion, and if you want some help setting that up. Maui's implementation of shadow is more full featured than Android's, and so maybe the native one can give better performance in general for you. And lastly, a nested data template. So I've seen where folks would put a collection view in a collection view or a bindable layout inside of a collection view. Um, those can also be trouble for performance because what happens is you're scrolling the collection view and a row goes off of the top of the screen and is recycled. And it actually will clear the binding context and then set it with the binding context at the bottom. And it basically recreates the nested data template completely from scratch as you scroll each row. So a workaround is if you can have a fixed number of labels. Let's say that you only want to ever show 3, or you want to show the max of 3. You can kind of flatten those into properties and bind the properties instead of having a bindable layout, right? And then you would just show and hide the labels if they need to be displayed or not, right? So these are just some ideas. I mean, we're always trying to improve these scenarios, but these are just some tips for now. So lastly, here's all the links that I have. Profile Maui is all about profiling. If you're wanting to specifically investigate memory leaks, we do have a wiki page for that. I'll put these in the video description. And also, so there's an Android specific profiling guide and an iOS and Mac Catalyst ones because each platform, the commands are a little different. I was running ADB commands for Android. iOS, it's obviously a little different. So yeah, so that's all I have. I just kind of hit record. I'm going to post this. Hopefully this is useful to someone. Thank you.